All right. Are you going to be able to focus on what I'm saying?
No.
Oh my gosh. Okay. Like, to be honest, no. Okay, you need to write this stuff down. Okay. So get your tablet how you want it, whatever's comfortable to write with. We're going to start by putting the properties of our cosecant function on here. Now, this picture that you guys see, the actual cosecant function is the pink u's, okay? Usually we see it graphed with the sine function in the middle because you can see where cosecant starts and stops. It's going to be at the maxes and min values of that sine function. So that's actually how we'll graph it in a little bit, is we'll make a sine graph like how we're used to, and then we'll use that sine graph to create the asymptotes and where our u's are going to turn around to get the graph of cosecant. Okay, so just focusing on the pink u's here, can you tell me the period, the width of one shape before it starts to repeat? It's a little bit bigger than pi because we have to consider the right side up u's and the upside down u's. 2 pi. Yep. So between like 0 and 2 pi, one right side up and one upside down would be a period. Same as sine. Domain, we're going to do the same way we did yesterday. All real numbers except what? Asymptotes. Range. There's going to be 2 parts to your range. Only the pink part is what we're looking at. So what's the lowest this graph goes? Negative infinity, and then it goes all the way up to what? Nope, there's a gap. -1, and there's a point there, so we're going to put a bracket. Union jumps to 1 to infinity. So we have a group in our range for the part that's upside down and the part that's right side up. Zeros are x-intercepts. Does the pink graph have any x-intercepts? No, none. Vertical asymptotes. We're going to do this the same way we did yesterday. We're going to pick a vertical asymptote on the graph. I think the easiest one to use here is 0 because my y-axis is an asymptote. Plus, how often do we see an asymptote? How many units do we have to go to get to the next one? Pi. So we're going to say plus pi k, where k is an integer. And it doesn't have to be 0. You could say pi plus pi k or 2 pi plus pi k, but it's an asymptote plus period times k. Even or odd? What do you think? This is odd. If you flip it upside down, rotation of 180 degrees, it looks the same. All right, were we able to get all of that information on our screens? I don't know, if you guys hit the little present button, does that make it bigger? There's a present button on the top right. It looks like a square, blue square with an arrow. Oh, no. Okay. Never mind. Can you zoom in? Like if you take 2 fingers and zoom? The writing on the pen bigger? I'm not sure. Did you guys try to zoom in at all? You'll get used to it. Does the zoom in work at all? No. Oh, you can't zoom in. I'll keep that in mind when I make our slide. We'll make sure we have enough room. Okay. When you're ready, go to the next slide. There's an arrow at the top. There's an arrow to the right. And you're going to see the graph of secant. I want you, with your partner, explain the properties of secant. Go ahead.
Yeah.
Okay. Oop. Let me make sure I've got the right. Okay. So period of secant is again 2 pi. Domain is all real numbers except the asymptotes. Range is the same. Zeros are the same. All of those first 4 pieces of information, all the same. Vertical asymptotes are slightly different. It starts, you can pick any asymptote as a starting place. I picked pi over 2 is an asymptote on this graph. But then again, they occur every pi units after that. So you should still have plus pi k, where k is an integer. And then this guy is even. If you look at that y-axis, you can see it's symmetric about the y-axis. Even function, yeah.
How do you know, like, to put pi before k and not, like, pi over 2?
So this number represents your starting asymptote. And this number represents the distance you have to go to get to the next asymptote. So if I'm looking at two asymptotes on this graph, they're pi over 2 and 3 pi over 2. They are pi units apart.
Oh, so you have the period then?
So for these, it's half the period, yes. Because we have two asymptotes within one period of the function. Other questions on this? No? Okay, we're just going to do one graph. We'll really test how accurate your writing skills are, I guess, with this one. We'll find out. Okay, so here are the steps that we're going to use to graph secant and cosecant. And you won't have to graph very many of these, you'll see why. So pretty much what we're going to do, if we see a secant or a cosecant, what we're going to do first is graph sine or cosine, using all of the steps that we did before. We're going to get the whole wave on our graph. Once we have the wave on our graph, anywhere where it's crossing the x-axis, a 0 is going to become an asymptote. Think about what we talked about with our unit circle. 0 and undefined are reciprocals of each other. And if secant and cosine are reciprocals of each other, so 0 and undefined, we're going to be seeing that same relationship. And then wherever you have a maximum point on your wave, that's going to be the bottom of one of the u's. Wherever you have a minimum point on the wave, that's going to be the top of one of your u's. And then that'll give us our function. So it's really just sines and cosines with that extra step at the end, adding in the asymptotes and the u's. All right, so here's our example. 3 secant 2x minus pi over 2. The 2 has already been factored out for you. Remember, if it wasn't, though, you'd want to do that first. What is the reciprocal of secant? Cosine. Okay, so we're going to do 3 cosine 2x minus pi over 2. That's what we're going to graph, and then we'll turn it into a secant graph at the end. All right, so same rules we've been using. How do I find scale changes? What are our little formulas? Reciprocal of b times x, which here that would be 1/2 x. And then not d. Scale changes are stretches and shrinks. What other number there does a stretch or shrink? A. 3 times y. Okay, reciprocal of b times x, a times y. Translations. The rules are x minus c, which here that's going to be x plus pi over 2, y plus d, which we don't have a d value. It's just going to be y. Okay, key points for cosines. Remember, sine and cosine are all the same. They start at 0 on your unit circle. Every pi over 2 units are the radians that we're using. Every quarter rotation around our circle. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now we need to give the cosine of each of those radian measures. You need to know your unit circle. What is the cosine of 0? 1. Cosine of pi over 2. Cosine of pi. 3 pi over 2. And 2 pi. 1. Okay. Scale changes first. We're going to do 1/2 times my x's, 3 times my y's. So my x's will become 0, pi over 4, pi over 2, 3 pi over 4, and pi. 3 times my y's will become 3, 0, -3, 0, 3. X plus pi over 2, y stays the same. 0 plus pi over 2, pi over 2. Pi over 4 plus pi over 2. You can think about that with a common denominator. Pi over 4 plus pi over 2. What's my common denominator? 4. So if I think of it as 2/4, 3 pi over 4. Pi over 2 plus pi over 2. A half plus a half. Pi, 1. 3 pi over 4 plus pi over 2, or 2/4. 5 pi over 4. And pi plus pi over 2. Think of it like 1 plus a half. 3 halves. 3 pi over 2. All the y's stay the same. 3, 0, negative 3, 0, 3. It's going to be rough. All right, graphing it. Pi over 2, halfway between 0 and pi. I'm going to go up to 3. 3 pi over 4, I'm at 0. Pi, I'm at negative 3. 5 pi over 4, I'm at 0. And 3 pi over 2, I'm back at 3. And that's 1 period of my graph. Do your best, I know. I'm going to graph a second period here, just sketching it out best I can. Okay, so remember what we see there is our cosine function. It is the reciprocal of what we had. Okay, so now, once you have that picture, here's how you turn it into a secant function. Anywhere that you are crossing the x-axis becomes an asymptote. So you can use your line tool even if you want, maybe, if you want to get fancy with it. Draw a line anywhere where you're crossing the x-axis. I think you have a line tool. Do you have a line tool? No, maybe not. Okay, just draw a straight line. Anywhere where it's crossing the x-axis. Okay. Then, where you have minimum points is going to be the top of a U shape. And where you have a maximum point is going to be the minimum. And the U shapes are going to be contained within those asymptotes. Okay, so it's going to look like, we're trying to at least get one period. It's going to look like that. That. Something like that. Something like that. So the graph that you see in black there, that's our secant graph that we're looking for. There and at the bottom. Okay, and the cosine in the middle is just the work to get us to that point. Okay. All right, properties. If you want to do period, you can look at the picture. You can also, because we use sine and cosine to get these, you can also revert back to that 2 pi over b. B here was 2, 2 pi over 2, period is pi. Domain, all reals except our asymptotes. The range, we can see in the picture, negative infinity to negative 3, and then it jumps 3 to infinity. Asymptotes. You have asymptotes anywhere where you graphed a 0. So you can use these points to help you. 3 pi over 4 in my picture is an asymptote. That's where it's crossing the x-axis. And 5 pi over 4 is an asymptote. So I can say when I list my asymptotes, 3 pi over 4 plus, and then you can think about what Luke said, it's either going to be half of the period, or you can just look at the distance between these. The difference between 3 pi over 4 and 5 pi over 4 is 2 pi over 4, or pi over 2. K, where K is an integer. It's not on here, but if it said zeros, you would say none, because there's nowhere that the secant graph is crossing the x-axis. It could also ask for phase shift, which is still just the opposite of C. So here that would be like a positive pi over 2, or right pi over 2. So none of that is different than our other function. Okay. That is the end of our 5-5 lesson. Yes?
I like the open up quiz.
Oh, let's talk about the quiz. Okay, so due to impending snowfall, because we're all very concerned about that, I know. So what we're going to do is we're going to change the format of that a little bit. So tomorrow in class, first of all, remember, we're going to talk about registration. I'm going to meet with you guys individually. You're going to be working on a quiz review, and I'll have the answers posted in Polaris. At the end of the period tomorrow, I am going to give you your quiz. It is turning into a take-home quiz, okay? So yes, it's open note, and you can use whatever you want on it. If we have school on Thursday, you will have the whole period on Thursday to work on it as planned, and it will be due at the end of the period, okay? If we do not have school on Thursday, you will just turn your quiz into me the next time you see me. Friday when you walk into class, Monday when you walk into class, whenever that is. Okay, so if you're living in a dream world and we don't have school Thursday or Friday, you will just turn your quiz into me Monday when you return to school. Does that make sense? So that way too, if we have a snow day, we really don't lose a day. We don't have to like change our calendar around and stuff. Your quiz is becoming a take-home quiz. All right? So that's the plan for tomorrow. I'm going to talk to you guys about registration stuff, so kind of have some sort of idea of what you're thinking for next year, or at least a list of questions that you want to kind of chat about with me if you're unsure, if you're deciding between a couple things. We'll get those course recommendations in. You guys can practice. Do you guys want to practice on these tomorrow again, or do you want a worksheet or these? Okay, I have the worksheets printed already, so I'll let you guys use these tomorrow if you want to. I'll make it a Jamboard format for you, so if you want to use it, you can. Okay, and then we'll meet. And 5.5 Math Excel, I'm changing to do, it was originally due Thursday night, I'm just gonna make it due Friday night, just so you have an extra day, and maybe you don't have to use your whole snow day if you get one. What about what? It's still due Friday night. Don't push it. All right, good? Yeah. All right, so you guys, I'll do the cell phone lotto. You got about 15 minutes. If you want to play with these a little bit, that's fine. Just make sure when you're done, you log out, shut it down, because another period is going to use this. Okay, so we don't want them logging into your account. I mean, if you really want to, just, I guess, go ahead. Just don't download anything. Anything you do, keep it internet-based for me so we don't, like, waste any storage space on the device, okay?